contributing to A intersection B. In the similar manner, this one is contributing to A intersection C, and this one is contributing to B intersection C. Wherein, if we are interested in finding the intersection of all the three sets together, that will be represented using this section. This is representing A intersection B intersection C. Common elements in all the three sets. Moving further to this. Now, whatever we are going to cover in this week related with set theory is very crucial considering your higher studies, as well as if one wants to score good in discrete mathematics, you should not skip this part. Okay, this is the mandatory, whatever we are going to look for. Okay, so there is a concept of mutually exclusive and exhaustive sets. Okay, what do you mean by exhaustive set and what do you mean by mutually exclusive? Let us see. We say that a group of sets is exhaustive of another if their union is equal to that set. For example, if you are getting A union B is equal to C, we will say that A and B are exhaustive with respect to C. What is the meaning of exhaustive set? Let us say there are three sets A, B, C. We are taking union of two sets A and B, and if the result of union operation of A and B is exactly equal with third set C, we will say that set A and set B are exhaustive with respect to set C. Some concept, okay, new concept, no exhaustive set. I have discussed this mutually exclusive while discussing few examples in the last lecture. We will say that any two sets A and B are said to be mutually exclusive if their intersection is phi. If there is no sharing of elements in between the two sets, we are going to say it as A intersection B as a phi. Those will be treated as mutually exclusive. Okay. This is very important. Okay, we are going to use this principle for solving many examples in today's lecture as well as the coming lectures for set theory. The principle of inclusion exclusion. What do you mean by principle of inclusion exclusion? This principle will allow us to find the cardinality of union of sets by knowing the cardinalities of individual sets and all possible intersections of them. The basic version of principle of inclusion exclusion. You might have seen this in your earlier mathematics. Okay, if I am interested in knowing the cardinality of A union B, that will be nothing other than cardinality of set A plus cardinality of set B minus cardinality of A intersection B. Again, a question would arise, why we are subtracting cardinality of A intersection B? Okay, you could observe whenever we are taking union, we will have all elements of set A as well as all elements of set B. Okay, there might be some elements which are common in A as well as B. So while taking union, there will be repetition of same elements. And as per the definition of set, we want only distinct elements. So there is a need of subtracting common elements which are present in both. I will take this with the help of example so that your things will get clear. Okay, why this minus A intersection B happens to be? Okay, how it happens to be, that is the reason. Okay, I hope this is clear. In case it is not clear, okay, what will be the principle of inclusion exclusion for mutually exclusive sets? If we are having A and B as mutually exclusive, then there will not be any need of subtracting A intersection B because it will be phi. We will be simply adding the cardinalities of individual sets A and B. This principle of inclusion exclusion can further be extended with the three sets wherein I will have cardinality of A union B union C equal to cardinality of A plus cardinality of B plus cardinality of C minus cardinality of A intersection B, A intersection C, B intersection C, and we are adding cardinality of A intersection B intersection C here. Okay. So these are the two formulas which we will be using throughout while solving all the further examples. Okay. So before moving further, okay, let me show you quick proof of this, how A union B is equal to cardinality of A plus B minus A intersection B, how it happens to be. Okay, whether it is clear whatever I'm saying, whether it is clear up to this point. Do you remember we that you have studied these principles somewhere past in your earlier mathematics? Have you studied? Have you studied? Okay. Abhishek is saying yes, and others have not studied. Okay. Anuraj is also saying yes. Okay. No, Viraj has not studied. Okay. Okay. No issue. No issue. No problem at all. Okay. So even though you have studied or not studied, let me provide you a proof. Okay. So observe. I am going to prove this principle using the laws which we have discussed for set theory. Okay. So how can we write? Let A and B are two finite sets. I must say finite sets. Okay. Those are not mutually exclusive. Those are simply two finite sets. Okay. How can we write set A in terms of A intersection B and A minus B? Can you tell me? How can we write? How can we write set A in terms of A minus B and A intersection B? Okay. I can write A is equal to A minus B. What are the elements which will be present in A minus B? Those will be exclusively available in A but not in B. I am saying union A intersection B. So I think this is clear. Okay, we can represent the set in terms of union operation, wherein I am taking A minus B union with A intersection B. So obviously, whatever is present in between A minus B and A intersection B will be nothing other than the elements of set A. We are having one principle known as addition principle. So what that addition principle says? Addition principle says that whenever there is union, you have to take addition of cardinalities. So you can say cardinality of A is equal to cardinality of A minus B plus cardinality of A intersection B. This addition principle. What is the addition principle? Addition principle says that cardinality of A union B will be equal to cardinality of A plus cardinality of B. Whenever A and B are disjoint, I am saying. Okay. In this case, okay, let us assume this as A and let us assume this as B. Whether these two are going to share anything, whether there will be anything common in between A minus B and A intersection B, I think there will not be anything common. So this one and this one are mutually exclusive. So I can write cardinality of A is equal to cardinality of A minus B plus cardinality of A intersection B. Is it making a sense or it is making confusion? Can you tell me in chat box whether it is making a sense? Whatever is being discussed. Okay, whatever it may be, even though it is not making a sense, it will make a sense afterwards once I take an example. Okay, no problem at all. So we have written cardinality of A equal to cardinality of A minus B plus cardinality of A intersection B. How can I write it further? I can write it further like cardinality of A minus B is equal to cardinality of A minus cardinality of A intersection B. Let us keep this as some corollary. Okay, this will be crucial in further parts. Okay, corollary. Let's have this. And what to prove? I have to prove cardinality of A union B is equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. This we have to prove. Okay. So So for proving this, we will make use of this corollary somewhere. That is the reason why I have shown you this corollary, nothing else. Okay. Let me go back to PPT and I have to show you something so that the things will be more clear. Okay. Uh, where is my PPT? This one. Okay. So where is this blank space? How can I draw? Okay. So just observe whatever I am drawing. Do not observe on the examples. We have discussed examples earlier only. Okay. I am drawing a Venn diagram for your understanding, nothing else. This is set A. This one is set B. I hope I have drawn quite good Venn diagram. Okay, using mouse, and that is quite difficult. You can check at your end. Okay. So this one is set A. This one is set B. Okay, set B. So this shaded region, okay, this thing, whatever I'm shading, how can we represent this shaded region? The shaded region is known as A minus B. Up to this point, I think there is no problem. We are finding A minus B, and that is this shaded region. And what is this intersection? That we know this is nothing other than intersection of A with B. This Venn diagram is with you. Okay. Okay. If you are with this, okay. Can you tell me now? Okay, just look out at this diagram. We have to prove cardinality of A union B is equal to cardinality of A plus B minus intersection. So my question is, how can we write A union B in terms of difference? How can we write A union B in terms of A minus B and something? I'm expecting now your answers in the chat window. My question is, how can we write A union B in terms of A minus B? Venn diagram is in front of you. So question is, I have to write A union B. I am asking what it will be equal to. A union B is equal to what? We have to write in terms of difference. Think over it. Yes, somebody has given the answer. Who? Many. Okay. Anurag is saying A minus B plus A intersection B plus B. No, I'm asking in terms of union only, Anurag, because we will be making use of addition principle thereafter. Addition principle is applicable for all mutually exclusive sets, wherein instead of union, you are putting addition of cardinalities. So somebody has given the answer A minus B union B minus A union A intersection B. Rohan is saying A minus B union B minus A union A intersection B. A minus B union B minus A union A intersection B. Okay. Okay. Perfectly fine. A minus B union A intersection B union B. Anuraj, you are near to the answer. Okay. A minus B union A intersection B union B. Whether there is a need of including A intersection B, because whatever are the things in B, those will be present in A intersection B. Yes, Rucha is fine, correct. She is saying it is A minus B union B. Again, an obvious question could come, why our answers are wrong and why only this one is correct? Because we are now looking in terms of two mutually exclusive sets. Those should not share anything. So this one, A minus B and set B, will not share anything. You can observe what she said. A union B is equal to A minus sorry, A minus B. She is saying union. This one is union. Okay, union B. Are this mutually exclusive? What is A minus B? This one. What is B? B is this entire thing. Whether they are sharing anything? No. So those are mutually exclusive. This one. Okay. So the answer for writing A union B, we are writing A minus B union B. Let me go back to notepad and solve the equation. Okay. So I can write A union B is equal to A minus B union B. Why I am writing in this term? You can write A union B in any manner, but while writing you should take care that both of the sets are mutually exclusive. They are disjoint. They are not sharing anything. Why so? Because we want to make use of addition principle, which says by addition principle, cardinality of A union B is equal to, what is that? Cardinality of A minus B, instead of union put plus cardinality of B. Okay, this is further equal to cardinality of A union B is equal to cardinality of A minus cardinality of A intersection B plus cardinality of B. How I am directly writing this? Using corollary. Therefore, what is my answer? A union B is equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. See why I have shown you first corollary. Here we have seen corollary. What is that corollary? We were able to write symmetry difference in terms of A minus A intersection B. Further to this, for proving this principle of inclusion exclusion, we have written A union B as union of two disjoint sets which are A minus B and B. I have made use of addition principle, which says that if there is union operation in between two sets and those two sets are disjoint, then we can simply add up their cardinalities. So you are getting the result as cardinality of A union B is equal to cardinality of A minus B plus cardinality of B. Further to this, this symmetric difference can be represented as cardinality of A minus cardinality of A intersection B. I can rearrange these terms. So I'm saying cardinality of A plus cardinality of B minus cardinality of A minus B. This is known as principle of inclusion exclusion for two sets. This you will be using, okay, for solving your problems. Which one? This. Okay. Principle of inclusion exclusion. Is it fine? Are you getting how I have proven the principle of mutual exclusion, inclusion exclusion? Okay, not mutual, only inclusion exclusion. Is it fine? Nobody is going to ask you proof. Okay, but I have given you proof as well. They will ask you directly problems wherein you are supposed to use these proofs. Nothing else. Okay. No. This is applicable for two sets, but in case we are having three sets, how can we find A union B union C? We can find A union B union C using the formula cardinality of A plus cardinality of B plus cardinality of C minus C here. For two sets, we are taking minus of intersection. In the similar manner, we are first adding cardinalities of individual sets. Thereafter, we are subtracting. Subtracting what? We are subtracting cardinalities of two set intersections. Okay, so B with C, and next A with C. And thereafter, finally, this one is important. We have to add up whatever is present in between intersection of all three. Again, somebody will ask me, okay, what is the proof of this? We can prove this using the concept of Venn diagram, as I have shown you for two sets. In the similar manner, you can provide a proof for three sets, wherein you would see that there is a need of adding the intersection of three sets finally. Okay, this will be applicable for third. Is it fine? Keep these two formulas in mind. Okay, we have to use this throughout. Okay. Okay, now let me give you a proof, a small proof, okay, with the help of example, so that you will not say that. Let me say 1, 2, 3, 4, p equal to 2, 4. Can you tell me what is A union B? Okay, instead of you are telling, okay, I am directly writing 1, 2, 3, 4, 5. Okay, see how I have written A union B? I am not supposed to have duplication. So what is the cardinality of A? It is 4. Cardinality of B, 3. Cardinality of A union B, it is 5. How it is coming 5 using formula? I know that in intersection I am having 2 comma 4. So let us cross check whether our formula holds to true. So what is our formula? It is saying cardinality of A union B is equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. So I will put out the values and check out. This is equal to, what is cardinality of A? That is 4, plus cardinality of B, 3, minus, we have to subtract the common elements just to avoid repetition. So how many elements in common? 2. So it comes out to be 5. Do we have cardinality of A union B as 5 in our answer? 1, 2, 3, 4, 5. Yes. So principle of inclusion exclusion is proven with the help of example. Is it clear? Why there is a need of subtracting? Yes. Yes. Okay. So let's go for the actual examples now, if it is clear. Okay. Okay. So the very first example that is solved for you. Okay. Let A equal to A comma B comma C comma D and B is equal to C D E F with the cardinalities 4. Their union I have shown you. Okay. Even though C and D are common, we are writing C and D only once. So in intersection we are having C comma D. So what is A union B? We get 6. So this is the example that we have to solve. Okay, I will solve first and thereafter you are going to solve two more. Suppose that in certain exam 200 students appear for mathematics, 50 appear for physics, 20 appear for both maths as well as physics. How many have appeared for physics or mathematics? We have to solve this step by step. So what is given in certain exam? 200 students appear for mathematics. So that means I know the cardinality of mathematics. What is the cardinality of mathematics? It is given as, let me write it in notepad for faster. Okay, faster way. So let me here. Let how to solve the problem that I am showing you. If you are not solving problem in this manner, I am going to give you only 1 mark out of 6 in the examination, final exam. Okay. Let M denote set of students who appear for maths exam. Let P denote set of students who appear for physics exam. Okay. Then further to this, we have been provided cardinality of M is what? Let me check in the example. Cardinality of M, 200 appear for mathematics, 50 for physics. That is given. M is 200 cardinality. Okay. cardinality of P 50. Further to this, they have given 20 appear for both. There is usage of and. Whenever there is and used in the statement, we have to go for intersection. If it is mentioned or, you'll be using union. So it is given M intersection P. This value is equal to 20. This is given. And what is asked to find? See the way I am writing the solution, I am expecting the same type of solutions from your side. Okay, to find the total number of students who have, let's observe what is given, appeared for mathematics or physics examination exam. That is, we need to find M union P, its cardinality. This is unknown, that we have to find. Okay. Solution by principle of inclusion exclusion of sets. Cardinality of M union P is equal to cardinality of M plus cardinality of P minus cardinality of M intersection P. Further to this, so this is equal to 200 plus 50 minus 20. So I'm getting my result as 230. This is what? This is M union P. As this. Okay. I have seen that students are writing only this. No, you are supposed. Therefore, 230 students appeared for mathematics or physics exam. I'm expecting the solution in this manner for each and every problem, either in examination or the assignments. You'll be first defining what you are assuming. After defining, write the appropriate cardinality values as given. Thereafter, write to find. What to find in terms of statement form. Then you are converting the statement form in the symbolic notation. Thereafter, you are making use of the available theorems and principles for finding your final answer. Am I clear? Whether it is clear how we have computed the number of students who have appeared for either physics or mathematics? You will be following the same methodology. Okay, do remember. Okay, now let's check what is given in slide. Okay. Let M be the set of students appear for mathematics, P be the set of students appear for physics. It gives that these cardinalities, whatever I have written, we need to find union. So according to principle of inclusion exclusion, our answer is 230. You are keeping this at this point. No, you are supposed to further write total 230 students have appeared for whatever asked mathematics and physics. Can you solve for this? Can you tell me the answer for question number 2? A certain computer center employs 100 programmers. Of these, 47 can program in Fortran, 35 in Pascal, 20 in COBOL, and 23 in Fortran and Pascal, 12 in COBOL and Fortran, and so on. Okay, and 5 in all three. How many employees cannot program in any of these three languages? Something different. Okay, slightly changed now. Should I solve this, or will you be able to do? Should I solve this? Are you going to give a try? No. Okay. You are going to give a try. So go ahead. Go ahead. I'm waiting for your answers. So you are solving, I hope. Okay. In case you need my help, let me know. I will give you a solution of question 2 as well. Because we will be solving around 15 problems in these lectures, so that I will be able to cover up each and every type category of these sort of problems. Anybody has got the answer? Somebody is saying 39. Mahesh has got the answer 39. How about others? 39. Abhishek has also got the answer 39. Very nice. Okay. Viraj is saying 61. 100 employees do not. Yes. 100 employees do. No. Viraj, F union, P union C, 61 employees do program. There are total 100 employees. Okay. So you are saying 100 minus 61, 39. Correct? Correct, correct. Only thing is you should not write 100 employees do program. What is given? A certain computer center employs 100 programmers. Okay. So these are the number of employers present in a certain computer center. Out of these, it is further given this information. So your 39 answer is correct. 39. Okay. So 39. Very good. Okay. So should we see the solution now? Whether it is 39 or something different? Okay. So let us see what this slide is saying. Okay. I do not. So 39. Okay. So the answer is very good. Okay. First, we need to find the number of people who can program in at least one language. See here, there will be either usage of or there will be usage of at least. If it is mentioned at least, then also you are supposed to use union. So first, we are finding number of people who can program in at least one language, either Fortran or COBOL or Pascal or all three. So cardinality of F union C union P using again the principle of inclusion exclusion for three sets. We are putting out all the values and we are getting our answer at 61. So what is the 61 number? There are 61 employees who know at least one language. They may know all the three languages, but it is clear that they will be knowing at least one language. But what is asked? How many employees cannot program in any of these three languages? So I know that there are 100 employees. Let us treat this 100 as a universal set U, the number of employees, total number of employees. So cardinality of U is 100. I want what? Number of people who can program in none of the programming languages. That means I want F union C union P whole bar. I am interested in this one. Okay, I want to compute this bar. So how can we compute F union C union P whole bar? This cardinality will be equal to cardinality of U minus cardinality of this one F union P union C. So this will be the thing. So you are putting cardinality of U as 100 minus cardinality of F union C union P as 61. So your answer becomes 39. Very clear. Go for third one. Let me know the answer for third. If there is a percentage, you will be picking up direct values. That is 58, 75 likewise. Percentage symbol can be skipped. And while writing your final answer, again put the percentage symbol. So it is given that 58% of Indians like coffee and 75% like tea. What is the percentage of Indians liking both coffee and tea? 33%. 33%. Very nice. Does anyone has a problem of knowing A union B? Do you have problem of knowing A union B? What is A union B? In this case, 100, because it is mentioned in terms of percentage, isn't it? So you have to interpret by reading out the statements given in the Exam. Yes, A union B is 100. That is given. Very good. So you will have your answer as 33%. Okay, let me check whether your answer has to be, whether it is coming 33% or yes, 33%. All are correct. Okay. Consider that 100 people are there. So 58 like copy and 75 like T. So we are putting all the values accordingly and finding out this C intersection T, which comes out to be 33. So again, we are putting percentage symbol. 33 upon 100 into 100, that comes out to be 33 percentage. This is for you again. If I'm going fast, let me know. If something is not clear, again let me know. Okay. We are not having any hurry. In a class, there are 100 students, 39 play tennis, 58 play cricket, 32 play hockey, 10 play cricket and hockey, and so on. What is the number of students who play only cricket? This is something different. Okay, only cricket. Now it is mentioned only cricket. Okay, take the snapshot of this. You can try this as a homework and let me know the answer in tomorrow's class. I do have other problems to discuss for today. Okay, so take the snapshot and you'll be trying this. For trying this, you should be ready with some earlier problems that I will discuss first. Okay, so have you taken the snapshot? Yes, so take a snapshot. At least can you tell me what is the symbolic form that we want? What is the number of students who play only cricket? Let A denote students who play cricket, B denote students who play tennis, C denote students who play hockey, and so on. So in terms of Venn diagram, I will show you what to find. Where should I draw Venn diagram? Okay, here. So this is my Venn diagram. This one is hockey. This one is tennis. And this one is cricket. I want only cricket, isn't it? So only cricket. You'll be interested in finding this shaded portion except anything which is in shared with others. This one we have to find. What is the number of students who play only cricket? Have you taken the snapshot? Yes? Yes or no? Okay. Yeah, I think you are now gone in the mode of solving this example. Yes, you can try. I do have others. Yes, you have taken the snapshot. So example number how much? Three. Fourth one is given for exercise. Example number five. Okay. Example number five in front of you. Okay. In a survey of 70 students, survey of 70 students, it was found that 40 read times, 30 read, 30 read card, and 20 read both. 20 read both. Okay. I want what I want. Fine. How many read at least one newspaper? B. How many read neither? This I want in today's class answer for this. Okay. So this is one question, and other one also I will write. Okay, and you will be solving both, and let me know the answers in today's class only. Among the integers from 1 to 300, Find how many are not divisible by 3 or 5. How many are divisible by 3, not 3. So let me know the answers of both. Unless and until we are clear with these basics, okay, it will be harder to solve that cricket and tennis example. That is the reason why I have taken these first, nothing else. So if your answers are ready, you can go with the answers. 35. Okay, 35 is the answer for what? T. 50 and not 35, 50. Okay, 50 and 20. You are saying answer is 50. At least one newspaper mean as I have to find union. Okay, so 40 plus 30 minus 20, this comes out to be 50. Very nice. And how many read neither? It will be universal set U minus neither means we have to compute A union B whole bar. Okay. Or A bar intersection P bar. That is nothing other than A union B bar using De Morgan's law, which is difference between universal set U and union. This comes out to be 20. Is there anyone who has not understood how this 50 and 20 comes? Feel free to discuss. Okay. Otherwise, I would not know whether you are getting or not getting. Explain. Okay. Viraj is saying explain. Yes. I'm expecting the same. Okay. You should not rely. Okay. How it is coming and not. Yes. What is first? So you will be first writing let U denote total number of students. So cardinality of U. What is given? The number of students. Cardinality of U given is 70. Next, let T denote the number of students who are reading times. So what is given? 70 students, survey of 70 students. So we have written cardinality of U. Cardinality means number of students present in particular set, that is 70. Next, it was found that 40 read times. So what is the cardinality of T? It is 40. Further to this, it was found that 30 read Sakar. This is mentioned. Okay. So cardinality of S is 30. Further to this, it was given 20 read both. Reading both means P intersection. Yes. What is this? This is 20 given. What is asked? How many read at least one newspaper? How many read at least one newspaper means what? I have already told you. Reading at least one. What is the meaning of at least? At least one or many. Minimum one. That is the meaning of at least. Okay. So whenever there is usage of at least or you will be using union. So what is asked? We have been asked to compute P union S. This is asked for the bit E. So for this, I am having formula cardinality of P union S using principle of inclusion-exclusion. This comes out to be cardinality of P plus cardinality of S minus cardinality of P intersection S. If you put the values 70, 40, 30 and 20, you will get your answer as 50. Did find how this P union S comes using principle of inclusion exclusion. Okay. How 20? Yes, yes. I'm going to show you how 20 as well. Okay. Wait, whether answer of A is clear? Yes. Okay. Now let's check how the answer of B comes. Okay. So what is asked in B? How many read neither? Okay. First of all, tell me If I ask you how many read either, what is the symbolic representation of how many read either? You are going to tell me in the chat window. What is the symbolic representation of how many read either? Either means either times or sakar. Either. Either is used along with or, and it is not used along with and. Aditya. So if I am saying either, what is the meaning of this either? Does it make a sense? How many read either? If it is mentioned how many read either, you are going to use this T union S. Okay. Yeah. Yes, yes. Wait for a while. Wait for a while. Okay. How many read either means this one. T union S. And if it is asked, how many read neither? What is opposite of either? Neither this nor that. So how I am going to represent neither this nor that? That is nothing other than cardinality of T union S bar. Whether it is fine. If it is read either, we are taking union. If it is read neither, neither this nor that, that means it is complement. Complement of what? This. Is it clear how this comes in symbolic notation? Whether this is clear, how this is coming? All are clear? Okay. Yes. Okay. Okay. If this is the thing, okay. Now remember our formula. We have discussed that formula. Okay. 2 to 3 lectures back, I suppose. Okay. If you remember. How can we represent a complement? Complement of a set is equal to universal set U minus A. Do you remember this formula? A bar is equal to U minus A. Whatever is exclusively available in U but not in A. Do you remember this formula? If you remember this formula, instead of A, we have to put what is asked? T union S bar. What it will be? It will be U minus what is A? A is T union S. This we have. So using addition principle, what can I write? Using addition principle, I can write cardinality of negation of T union S. That is nothing other than bar. T union S bar is equal to cardinality of U minus cardinality of T union S. This is further equal to, do we know what is cardinality of U? Yes, it is given. There are total 70 students minus how many students are reading at least one? That means either. This is 50. So what is my answer? 20. There are 20 students who read neither of the newspapers. I hope it is clear now at least. Still, if you are having confusion, let me know. Do you have confusion still? Have you understood how this is coming? So always remember, if there is usage of or at least, we have to make use of union. If it is mentioned and, we have to make use of intersection. No confusion at all. Okay. So now about this. Give a try. We are having 5 more minutes to conclude with this lecture. Okay, give a try. One 60 and 86. Correct. Akshada, correct. Abhishek, wrong. The answer is 160 and 86. Correct. Very good. Okay. Akshada, would you like to share your screen and show to your friends? No, no. The answer is 160 and 86. Okay. So again, take this as an exercise. Okay, I know that you want to go for your next lecture and it is almost 10:15. So take snapshot of this. I will start with the solution of this in tomorrow's class. So till the time, if you are able to get the answer is 160 and 86. The answer for this should be 160. Answer for this should be 86. Just check out. Do not ask whosoever has already solved. Okay, you will be solving on your own. Is it fine? Okay. So now turn on your cams, video cams. Okay. Give a try. Otherwise, I will start with the solution of the same in tomorrow's class. No problem. Not to worry. Can you turn on your cams? I have to mark your attendance. Yes. Quickly turn on your cams. Okay. Abhishek. Then who else? Okay. Aishwarya, Atharva, Anuraj, Prithviraj. Okay. Who else? Prathamesh, Onkar. Okay. Swapnil. Swapnil. Okay. You are not regular for my lectures. Mahesh. Okay. Who else? Abhishek Khamkar. Okay. Okay. Then who else? Who else? Anuraj. Okay. 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 Good to see you all. I have recorded your attendance. You can turn off and you can simply leave this meeting. Have a good time. Thank you.